So this is the question. So the gravitational potential energy between a point on surface of Earth and a point 20 meters above it, this much. This is the potential difference. Clear? Then calculate the work done in moving a body of mass of 4 kg by 8 meters on a line of which is having a slope of 60 degrees with respect to horizontal. What is the meaning of this question? So this is the surface of Earth. Clear? This is one point. And come on, so there is one more point which is at a height of 20 meters. 20 only, no? 20 meters. Clear? So potential difference between these 2 points is how much? This much. 16 joules per kg. Okay. Then I want to move a mass of 4 kg by 8 meters distance on a line which is having a slope of 60 degrees with respect to horizontal. Then what is the work done? Have you understood anything? Okay. Potential difference between these 2 points is given. And what is the distance between these 2 points? 20 meters. Clear? Now I want to take 4 kg body in this path. Then how much work I have to do? That is the question. Clear? What is meant by potential difference? Work done to lift a unit mass. That is called as potential difference. No? It means that from this point, if I want to take 1 kg mass, how much mass? 1 kg mass from here to here. Then how much work I have to do? 16 joules of work. That is meant by 16 joules per 1 kg, no? What is meant by 16 joules per 1 kg? Joules means? Joules means what? Amount of work done. Kg means? Mass. 16 joules per kg means? For 1 kg mass, I have to do how much work? 16 joules of work. To lift from which position to which position? From a position of here to here, whose distance is 20 meters. That is the meaning of this one. Clear? So similarly, if I want to lift 4 kg mass in this path, how much work I have to do?
64.
No. How can I do? So first of all, let us draw that path here. So what he is saying, length of the path is 8 meters, no ma? You are thinking too much, I think. So this length is how much? 8 meters, no? What is this angle? 60 degrees. What is the mass I have to lift? 4 kg. Clear? Now I am not moving in a straight line. I am starting from here. I want to take this point up to here. Clear, ma? And what is the slope? 60 degrees. Then how much work I have to do? That is the question. To lift a height of 20 meters, how much work I have to do? 16 joules for 1 kg. Clear, ma? Now how much height I am lifting? No, 8 is this length. But gravitational potential energy depends on vertical height, no? Gravitational potential energy depends on what? This height. So we are supposed to calculate this height, how much we have lifted. How can I calculate this height? 8 cos theta, 8 sin theta. That's all. So this height is nothing but 8 sin 60. So 8 sin 60 is how much? 8 into sin 60 value is root 3 by 2, 4 root 3 meters. That's all. So to lift a height of 20 meters, I have to do this much work. This much work per 1 kg. Then to lift to a height of 4 root 3 meters, how much work I have to do? Again for 1 kg. You take the ratio. So therefore work done per 1 kg is equals to how much? What is this height? 4 root 3. What is this height? 20 meters. If you take the ratio, I will get a fraction, no? That's all. So multiplied by, and what is the work done? Work done is 16. So come on, this much work I have to do, no? This much work I have to do per 1 kg. But how many kgs I have to lift? 4 kg. Then what can I do? So multiplied by 4. So therefore total work done will be how much? 4 root 3 divided by 20 into 16 into 4. That is my answer. That's all, number. So to lift to a height of 20 meters, I have to do 16 joules. 4 root 3 meters means definitely I have to do less work. No? Clear? So 4 root 3 by 20 will give the fraction of heights. Fraction of heights multiplied by energy will give the fractional energy. For how many kgs? For 1 kg. But how many kgs I am lifting? 4 kgs. So multiply by 4, I will get the total work done. No? 20 point something we will get. Answer which he gave is 22.16 joules. 22.16 joules. That is our answer. Seema will explain this question. So, these are 2 planets. So, this is a planet of mass m, radius is a. So, this is a planet of radius 2a, but mass is 16 times of this one. Clear, ma? And from this bigger planet, I am projecting a body of mass m with a minimum velocity of v. Then what is this minimum velocity so that it can reach to the smaller planet? That is the question. Clear, ma? If I throw a body from here, it should be able to reach the smaller planet. Then what is the minimum velocity with which I can throw this body? That is the question. Have you understood? So think for some time and see how we can do this one. How we can do this problem. Seema. If I throw this body from here, initially this body is under the attraction of which planet? Is it under the attraction of this planet or this planet? Only this one. Understand, no? Because this is a bigger sphere and this mass is very close to this planet. So definitely it will be under the attraction of this planet only. Understand? This also attracting this one, but force of attraction is very, very less. Okay. So definitely on this line, the line connecting between centers of these 2 planets. So there will be one point where gravitational force of attraction due to both the planets will be equal. So there will be one point, no? For example, if you take this point, force of attraction due to bigger planet is in this direction, F1. Force of attraction due to smaller planet will be in this direction, F2. That's all, no? When these 2 forces become equal, then what is the net force acting here? 0. So minimum, if I can send a body exactly up to here, then this planet will attract this body and this body will go to the smaller planet. That is the condition. Are you able to understand, ma? So how much velocity I have to give to this body? So minimum it should be able to reach this point. Which point? Where gravitational force of attraction is 0. Are you able to understand? If it can reach this body, then the smaller planet will pull that mass because of inertia. Are you able to understand? So first of all, let us search for this point where gravitational force of attraction is 0. How can I calculate? So very easily I can calculate if I take E1 is equals to E2, no? What is meant by E1 is equals to E2? Gravitational field intensity. Gravitational field intensity formula? Force experienced per unit mass. This is also force experienced per unit mass. So force experienced per unit mass due to this planet and force experienced by the other planet, if they are equal, then I can say field intensity is equal. That is the definition of field intensity, no? So by directly equating F1, F2 also you can do. I am doing in this method. Clear, ma? Then, come on, ma. What is the equation for field intensity? Minus Gm divided by R square. That's all, no? And I will measure R from here. So let this distance be how much? R. Clear, ma? Similarly, what is the field intensity due to bigger planet? At this distance I want. From here, this distance I have calculated to, I have assumed to be R. Understand, ma? This is that point where F1 and F2 are equal. Clear? From here, what is this distance? R. Similarly, what is the field intensity due to bigger planet at this point? Minus Gm divided by this total distance is 10A, no? From 10A, if you remove R, then I will get this distance, no? So therefore, what I will write? 10A minus R whole square. That's all, no? And what is the mass of the bigger planet? Mass of the bigger planet is 16 into M. Clear? So field intensity due to first planet and field intensity due to second planet, they are equal at a particular point. That point I am calculating. Are you able to understand? So therefore, what can I do? M and M, G and G, minus and minus get cancelled. So 1 by R square is equals to 16 divided by 10A minus R whole square. So take square root on both sides. So 1 by R is equals to 16 divided by 10A minus R. Then cross multiply. 16 square means this becomes 4, no? 4. So therefore, 4R is equals to 10A minus R. So therefore, 5R is equals to 10A. So R is equals to 10A divided by 5 is equals to 2A. Understand, Amma? So what is meant by this R is equal to 2A? So this is that distance where gravitational field intensity will become 0. Gravitational field intensity means what? At this point, force experienced by the mass due to both the planets will be equal. Understand? Okay. So now I will use the law of conservation of mechanical energy. Clear, ma? Law of conservation of mechanical energy. So let this be point P. Clear? And let this be point A. So energy at point A should be energy at point P. That's all, no? So here there are no external forces acting, no? All the forces are only internal forces only. So definitely I can use the law of conservation of mechanical energy. What is meant by law of conservation of mechanical energy? The sum of kinetic energy plus potential energy should be equal to final kinetic energy plus final potential energy. That's all, no? Okay. Now can you say what is the energy of this body here? Can you say? Kinetic energy is there half mv square. So one energy is half mv square. Clear? Now what is the gravitation potential energy it is having? Gravitational energy. So because of this sphere, what is the energy it has? So minus G mm divided by, and what is this what you called radius of this planet? 2a. So 2a. That's all. So only this much energy it is having. So this planet is also having some potential here, no? Are you able to understand? And what is the potential of this planet at this position? So gravitational potential energy means what is the meaning of this one? V into m. That's all, no? V is equals to W by m. Then W is equals to V into m. So mass of the planet is m. Therefore, what is the potential of this small planet here? Minus Gmm divided by, from the center of planet, what is this distance of this point? 10a minus 2a. How much? 8a. So therefore, how can I write half mv square minus Gmm divided by 2a plus potential is minus Gm by 8a into m. That's all. So this is potential energy due to first planet, bigger planet. This is the here also mass is how much? 16, no? So 16 m into m. That's all, no? Then this is the gravitational potential energy due to smaller planet. Are you able to understand? Are you able to understand? So this is the kinetic energy, potential energy due to bigger planet, potential energy due to smaller planet. This should be equal to how much? This should be equal to final energy. Okay, that is energy at point P. Now at point P, what is the energy possessed by this mass m? How much energy it should have? It should have kinetic energy, potential energy, or both kinetic and potential? Only potential energy. Why? Because that is the minimum velocity with which we are throwing, no? So this is the minimum velocity such that if it reaches here, its velocity should become 0. So at this point, which energy it has? Only potential energy. Due to how many planets? Due to 2 planets. That's all. So substitute that one. So that is how can I write potential due to planet 1 plus potential due to planet 2 into m. That's all. Now at this position, what is potential due to this planet? Minus Gm divided by, what is this distance? 2a. R means 2a only, no? Minus gm divided by 2a. Then what is the potential due to bigger planet again at this point? Minus gmm divided by 8a. So that is the total potential multiplied by mass. Then what is the only unknown quantity? Only unknown quantity is V. That is our answer. Have you understood? That's all. Make a note of this one. So therefore, half mv square minus 16m into g into small m divided by 2a minus gmm divided by 8a is equals to potential due to small sphere at point P is minus gm divided by 2a minus 16 m into small m divided by 8a multiplied by m. Oh, m already we have multiplied, no need of this. So therefore, from this you calculate V value. So that is the minimum amount of energy I require. Minimum amount of velocity we require. Clear, ma? Clear, ma? So V minimum is 3 by 2 into square root of 5 gm divided by a. That answer we should. Now let us see this question. The gravitational potential difference between the surface of a planet and a point 10 meters above is 4 joule per kg. The gravitational field in this region assumed uniform is dash. So that is the given question. For example, this is the surface of the earth. Then potential difference between 2 points is given. The points which are separated by a distance of 10 meters. So, and the potential difference is 4 joules per kg. Then he is asking gravitational field in this region. Gravitational field is nothing but gravitational field intensity, or you can call gravitational field strength also. So which is given by minus dV divided by dr. So magnitude we will calculate. So magnitude of minus dV divided by dr is equals to, so dV value change in potential difference or change in potential is 4, and the distance between both the points is 10. So this is equals to Newton per kg. Now let us see this question. In a certain region of space, gravitational field is given by E is equals to minus k by r. Taking the reference point to be at x is equal to 0 with V is equals to V naught, then find the equation for potential. So at a certain reference r is equal to r naught, it is given that potential is V naught. So let us see how we can calculate the potential. So we know V2 minus V1 is equals to minus integration of E into dr. Limits are applied from r naught to r. R is any reference which we are supposed to take here. So V2 minus V1 is equals to minus integration of r naught to r. E value is given as minus k by r into dr. So minus minus get cancelled. So V2 minus V1 is equals to integration of k by r dr, and limits are applied from r naught to r. So k is a constant, I can take it outside. So V2 minus V1 is equals to integration r naught to r k 1 by r into dr. So integration of 1 by r is log r. So therefore V2 minus V1 is equals to k into log r, and the limits are applied from r naught to r. So V2 minus V1 is equals to k into, so log r minus log r naught. So therefore V2 minus V1 is equals to k into log r by log r naught. So therefore V2 and V1 value is V naught. So is equals to k log r by r naught. So V2 is equals to V naught plus k log r by r naught. So this will be the equation for potential at any position of r. The gravitational field in a region is given by 10 Newton per kg I cap plus j cap. Find the work done by the external agent to slowly shift a particle of mass 2 kg from the point 0, 0 to the point 5 meter, 4 meter. So here we are supposed to find out what is the work done by the external agent. See, we know work done can be written as force into displacement. So first of all, we are supposed to find out force which is acting on this particle. So we know E, gravitational field intensity, E is equals to F by M. So therefore F is equals to M into E. So therefore F dash can be written as M into E dash. So therefore F dash, I can write it as mass of the particle is 2 kg. So into E dash value is 10 I cap plus J cap. So therefore F dash is equals to 20 I cap plus 20 J cap. So this is the force which is acting on this particle. Now this force has two what you call the components. So along x-axis it has a magnitude of 20 and along y-axis also it has a magnitude of 20. So therefore we are supposed to shift this particle from 0, 0 to 5, 4. So therefore along x-axis also some work will be done, along y-axis also some work will be done. So work done along x-axis, force into displacement, force is 20 and displacement along x-axis is 5 minus 0. So therefore work done along x-axis is equal to 100 joules. Similarly, work done along y-axis is equals to again force into displacement. Force is 20 and displacement along y-axis is 4 minus 0. So which is 80 joules. So therefore total work done by gravitational field is equals to 100 plus 80 is equals to 180 joules. So it means that gravitational field is doing positive work. For example, if this is the direction of gravitational field intensity and if a mass is moved in the same direction, then definitely I can say force is acting in this direction and displacement is also in the same direction. So therefore work done by gravitational field will be positive. So this is positive work done by gravitational field. Now here we are supposed to take this mass very slowly. For example, this is the initial position. From here to here I have to take this mass such that its initial velocity is also 0, its final velocity is also 0. So change in kinetic energy is 0 in this condition. So to make kinetic energy to be 0, it means acceleration is 0. It means I have to apply equal and opposite force in opposite direction, and this is the force due to external forces. So therefore external forces I have to apply such that kinetic energy should become 0. So if this is the amount of positive work done, same amount of negative work I have to do such that its kinetic energy will not change. Or if I move a particle in the direction of gravitational field, then definitely I can say that the potential energy of this body will decrease. So decrease in potential energy, actually it should convert into increase in kinetic energy. But as we are applying external force, kinetic energy change has become 0. It means what is the work done by the field? Same amount of negative work should be done by the external agent. So therefore work done by external agent is equal to minus of, this is minus of minus, so I can write plus 180 joules. That is our answer. Dear students, now let us see this question. Gravitational field is given by E dash is equals to minus 2x I cap minus 3y square j cap. If gravitational potential is 0 at 0, 0, then find potential at 1, 2. This is the first question. If gravitational potential is V is equals to x square y, then find gravitational field at 1, 2. So this is our second question. So let us see how we can solve this problem. First let us see the first one. So gravitational field is given, we are supposed to find out potential. So we know that relation between E and V is E is equals to minus dV divided by dr. So we are supposed to find out the potential. So therefore I will write minus dV is equals to E into dr. So therefore dV is equals to minus of E into dr. Now if this is only a small change in potential, if I want the total change, then I have to integrate it on both sides. So therefore integration limits are V1 to V2, and here limits are R1 to R2. So therefore I can write V2 minus V1, because here integration and differentiation get cancelled. So V2 minus V1 is equals to integration of R1 to R2 minus E into dr. So V2 minus V1 is equals to integration of, now what is the value of E given? Minus 2x I cap minus 3y square j cap into dr. Dr can be written as dx I cap plus dy j cap. So I can write like this. Now if I try to integrate them separately, then I can write like this: V2 minus V1 is equals to integration of minus, here I will have I have minus also, so minus of minus will become plus. So integration of 2x dx, and the limits are applied from what are the limits? 0 to 1 comma 2, so 0 to 1 in x-axis, plus integration of, now the second one is 3y square dy, and the limits are applied from 0 to 2 here. So I cap dot I cap will become 1, similarly j cap dot j cap will become 1 here. So integration of 2x dx, integration of 3y square into dy. So V2 minus V1 is equals to integration of 2x is 2x square divided by 2, and limits are applied from 0 to 1. Integration of 3 into y, integration of y square is y cube by 3, so 3y cube by 3, and limits are applied from 0 to 2 here. So V2 minus V1 is equals to, so 2 gets cancelled, here 3 and 3 gets cancelled, so 1 plus y2 cube is 8 here, so 9 should be the our answer for change in potential. Now let us see the second question. So if gravitational potential is V is equals to x square y, find gravitational field at 1 comma 2. So already we know the relation is E is equals to minus dV divided by dr. But here E value is present in both x and y axis also. Then in that condition I have to use the concept of partial differentiation. So E is equals to minus dou V divided by dou x I cap minus dou V divided by dou y j cap. So here we are supposed to use only partial differentiation. So E is equals to minus dou by dou x of, and potential is given as equation of potential x square y I cap minus dou by dou y, and again y value is x square y into j cap. Now if I do partial differentiation of this x square y, it means I am supposed to differentiate only this x square, y becomes a constant here. So therefore E is equals to 2xy, so minus I will take common, 2xy I cap minus, now differentiation of x square y with respect to y here. So here x is a constant, now we are supposed to differentiate only y here. So x square y into j cap. So therefore E value is, now what are the where we have to find out this gravitational field at 1 comma 2. So x value is 1, y value is 2 here, so substitute these values. So minus of 2 into x value is 1, y value is 2 I cap minus x value is 1 again, so 1 square into j cap. So therefore E is equals to, so 4 minus 4 I cap minus j cap. So this is our answer. So if I want to find out the magnitude of E, then I can write, then E can be written as square root of 4 square plus 1 square. So is equals to square root of 16 plus 1 is root 17. So this is our answer.